Yo, what's up, guys? Welcome back to another video. And today we're going to be talking about something that seems very, very simple, but actually goes on to become very, very more complex and very more important once the time passes on, once you finish like middle school or something. So you might be guessing from where the title is, but essentially we're going to talk about the Pythagoras theorem. I don't even know how to spell it. I don't know how to spell it. That's not how you spell it. But look, essentially, the premise of the idea of the theorem is that you have a right triangle. This means that you have an angle of the right triangles that at least one of them must be a 90-degree angle. From here, the theorem states that if we have sides A, B, and C, let C be the hypotenuse, then we can find any length of the triangle with two of the lengths using the Pythagoras theorem, which is a squared plus b squared equals c squared. And so you might be wondering, well, how does this look like in practice? How can we actually apply this theorem? So first off, this is just a starting equation. It turns more complex once you get into trigonometry and once you get into all these different things. But as of right now, let's just imagine we had a triangle, 90 degree, and it has side lengths of 3 and 4. What would be the length of the hypotenuse? Well, since we know it's a right triangle, and since we have A and B, so A is equal to 3 and 4 is equal to B, we can do the Pythagoras theorem. So we would do 3 squared plus 4 squared is equal to c squared. From here, 3 squared is equal to 9 plus 4 squared, which is 16, equal to c squared. Add these up, 25 is equal to c squared. From here, we're not done because c squared is not c, because we have to find c, not c squared. So we root it. Therefore, c is equal to 5. So the length of the hypotenuse of a triangle with side lengths 3 and 4 would be 5. It seems pretty simple, but let's turn to something else. Now let's try to find one of the side lengths. So let's say we had a hypotenuse, right triangle with a hypotenuse of 13 and a side length of 12. What would be this? Well, first off, we have our equation, a squared plus b squared equals c squared. But we have c squared, and then we have 12, which is, let's say this is b. So we're trying to find a. So we know 13 is c and 12 is b. So what we can do here is a little bit of manipulation. We know a squared plus b squared equals c squared. Therefore, a squared is equal to c squared minus b squared. The reason why that works is because you can manipulate the equation like an equation, essentially. So you can just subtract b squared on both sides. So then you're left with a squared is equal to c squared minus b squared. From here, you just plug the numbers in. A squared is equal to 13 squared minus 12 squared. A squared is equal to 169. 13 times 13 is 169. Minus 12 squared, which is 144. A squared is equal to 25. We're not done yet. We have to root it. Therefore, a is equal to 5. And so let's look at another very famous example. And this is where I'm going to start getting into ratios. Let's say we had a triangle of side lengths 6 and 8. And 6 is equal to a is equal to b. We just use Pythagoras theorem, right? From here, plug everything in. 6 squared is 36, plus 8 squared, which is 64, equal to c squared. 100 is equal to c squared. Therefore, 10 is equal to c. So you might be wondering, or you might be curious to know that these two triangles are actually copies of each other. It's just that one is not multiplied by 2. However, 1 is multiplied by 2. And this is the cool thing about, theorems. If you change the ratio of a triangle, it still holds on forever. Like, if I were to double this to be 12 and then 16, it would still work. The side length would still be 20. That's just how amazing this theorem is. And I'll prove it right now. So let's say we double this. Let's say we double the side lengths. Now it's 12 and it's 16. Now, we already proved, I already said it's 20. I already said this is 20, but let me prove myself real quick. A squared plus B squared equals C squared, right? We have 12 squared plus 16 squared equal to C squared. 12 squared is 144 plus 16 squared. Let's do a little bit of multiplication. I'm mathematics. I don't like arithmetic. This is annoying. Shit. 3 carry the 3, i.e. plus 0. 6, 1, 6, 5. 256 equal to C squared. Now let's do 256 plus 144. Carry the 1 again. 400. Now we just have to root it. Oh, look at that. Wow. The theorem does work, doesn't it? 20 is equal to C. This is why I say this is like the perfect theorem to get when you're starting into algebra. It just makes so much sense. You could ratio it. You could find so many things with it. And it's essentially the basis of why sine squared theta plus cosine squared theta is equal to 1. It's just another right triangle. I made a video on that. Go check it out. But essentially, this is the premise of the Pythagoras theorem. We're just trying to find side lengths and use it to find the hypotenuse, or we can use the hypotenuse and one side length to find the other side length. As long as it's a right triangle, and as long as we have 2 of the lengths, we can find any length for the triangle. That has been the Pythagoras theorem. I spelled it wrong. Thank you for watching, though. Hopefully, I have a good Thanksgiving. And, like, share, subscribe. Please. I'm broke. Thank you for watching, and goodbye.